All right. Hello, everyone. Welcome to this Sunday science stream. Um, Someone left a comment. This is Vernon King. He says this will be interesting. Well, Vernon, I hope there's something here that um, I hope you take something away from this that's important and that resonates with you. Let me make sure I can see myself on YouTube. This YouTubing, it's a funny business. I haven't created content here since I was out west, and for whatever reason, even when you don't create content, your subscribers fall off. So I lost. Well, I won't say how many I lost, but I lost a couple. Go figure. Okay, so people are watching me, so I think that's evidence I can see myself. Um, yep, there's me. If you're just coming in, please hit that like button. I do not have a super chat over here. So throughout this stream, if you want to make a donation to the channel, my Cash App and PayPal are here. And thank you to those of you who are here for now. I know folks jump in and folks jump out. I know other streams are going on right now. And hopefully I can say something over here that holds your interest. This is more of an educational focus, less entertainment. I try to entertain as much as I can. But I appreciate you guys who have at least stopped through. If you're going to stop through, please at least hit that like button. The likes are free. Let me make an announcement over on my original channel, just in case folks over there want to come and hear what I'm talking about over here. Okay. As you guys can see, I'm coming to you live from Western New York, Buffalo. This is my mother's home. Well, this was my home too, from middle school up until 18 years of age when I moved out and went away to college. But I'm here. It's a little toasty in here. I feel a little warm. I don't want to run the fan because I don't want any background noise interfering with the stream. But if it gets too warm in here, you're going to see me reach back here and turn on the fan. Hopefully, it doesn't interfere with the stream. All right. Let me make this announcement, please. Again, those likes are free. Let's see. All right. I just made the announcement over there. So whoever comes to watch, that's whoever comes to watch. Okay. Let me switch back. All right. Everyone, I'm going to play the intro. And then on the other side, I'm going to jump in. I'm going to do some reading today. So hopefully that doesn't run people away. But this is interesting reading. It's going to be out of my wheelhouse to some degree because we're going to look back up at the sky and into outer space. My backgrounds personally are in pharmacology and toxicology, though I do have an interest in astronomy and the aerospace world as well. So I will see you on the other side of the intro, and then I promise I'm going to jump right in. All right. All right. Hello, everyone, and welcome back to my channel. My name is Dr. Anwar Youssef Dunbar, and this is Big Discussions 76, Science and Technology. Please like the stream. If you see fit, please share it. And also, if the algorithm brought you here, and if you're new, please subscribe. So, yeah, I'm going to make an effort to just jump right into what I want to talk about today. You guys know I have a newsletter, and I'm also working on a book project. But I'll say, I think strategically for myself and for the viewers, I'm moving towards sharing all that stuff towards the end, depending upon the audience. But once again, if you're just coming in, if you're new here, if you're gonna hop in and hop out, please hit that like button. Those are free, and I don't have a super chat over here, and this channel is not monetized. So if I say something or if I've said something of value over here and you want to make a donation, my Cash App and PayPal are here. Okay, so today's stream, you know, everyone, there's so much going on. There's so much I could talk about scientifically. The monkeypox, the COVID-19, is that still going on? Who knows? There's just so much to talk about. There's so much that I could cover. But something came to my smartphone this past week, and it's something that I've been thinking about since I started this channel. And I said, okay, well, I'm going to do a bit of a stream. Oh, not a bit of a stream. I'm going to do a stream on this topic. So today I'm going to talk about the sun, what the sun is, what it does. I'm going to talk a little bit about how it works. And then I'm going to talk about and start to ask questions about does all of that affect our weather patterns? And there's a reason I'm going to ask that question. For anyone who's just finding this and you're from the climatology / meteorology community, and if you disagree with anything I say, I welcome guests. And a couple of months ago, I did put out a request on Twitter to talk to anyone about climate change, any of the experts in that field, any of the scientists in that field. I did put a call out to that. No one said anything. So maybe it's just that I'm a small fish. But if I say anything here, climate related, or even astronomy related, that you have a dispute with or that you disagree with, number one, those aren't my backgrounds, but also the door is always open to come and have a discussion so that we can all learn. Okay, so I'm going to start this with a question. Well, two questions. These are going to be our guiding lights for today. Do you believe in science? What science do you believe if you do? Okay, I was someone close to me posed that question to me a little while ago. We were talking about climate change and global warming. Okay. So do you believe in science? Part of science is not just embracing one theory and one explanation for what's happening. It's kind of looking at all of them and considering all of them together. So for most of my childhood, we were taught about global warming. We were taught about, and then that changed into climate change. I'm here in Buffalo now. My mom watches MSNBC every night. And frequently when I come home, she talks about the polar bears losing their habitat, the ice caps shrinking. But there are other theories. I hope this video doesn't get removed. Guys, I'm going to turn the fan on. Hopefully you can still hear me. It's getting warm in here. Speaking of global warming, it's getting warm here. So I'm going to turn the fan on. Give me a second. For those of you watching, can you still hear me pretty clearly? Say yes. For those of you, I have a small group here. Can you still hear me pretty clearly? I have a fan going in the background now. It's just starting to get toasty in this room. Can you still hear me? Yes, no, maybe. Someone say yes. All right, J. King, thank you. All right. Not every house in Western New York, especially if it's an older house, has central AC. So my mother doesn't have central AC. So I should cool off right now. Okay, so do you believe in science? And if you do, which theory do you believe? I'm going to show you guys a book. I hope this video doesn't get removed to the YouTube algorithm. For those of you running YouTube, this is for science education and discussion purposes only. I'm not telling people what to do here. I'm not telling people what to believe. We're just having a discussion about science, and one that doesn't often get discussed. I'm going to show you guys a book. A coworker who has since retired shared this book with me. This book is entitled Dark Winter, and it was written by a gentleman named John L. Casey. It's a short read. If you're curious about such matters, I would encourage you to go and buy a copy. You can probably get it pretty quickly off of Amazon. It's a very short read, but I'll show it to you one more time. It's called Dark Winter, How the Sun is Causing a 30-Year Cold Spell. Okay. So the premise of the book, when we think about global warming and climate change, and I'm not saying those aren't valid and they're not real, but again, science is about considering all of the theories together. Okay, not just focusing on one. So when you talk about climate change and global warming, and when I have conversations with my mother when I come home, those are operating on the premise that we as humans are turning the dial up on the temperature of the earth with our cars and our coal plants and our carbon footprint, all the meat we eat. We're causing the sea levels to rise. Okay. What this book asks, and what this book introduces into the ether, or is ethos the right word? A lot of academics use the word ethos, but what that book introduces into our thought processes is that, are there processes beyond our planet Earth that are influencing the temperature and the climate on the Earth? So the Earth, we know, is not floating around in isolation. We are in a solar system with, we know that Pluto was demoted from a planet. So we are in a solar system with 7 other planets, and we have one central star. So the Earth itself, there are numerous ecosystems and communities with organisms on the Earth, and the argument can be made that the Earth is in an ecosystem, a solar ecosystem, with the other planets and the sun. And then the question is, what are there other factors outside of our atmosphere that are influencing the weather patterns that we see? And I'm going to jump into that. And so we know that there are different spheres within the Earth. There's the hydrosphere, the atmosphere, the biosphere, the lithosphere. So there are all these different things. The weather patterns are influenced not only through biology, but also through the chemistry of the ocean, the chemistry of the atmosphere. As I'll describe, as I'll show, the Earth itself has its own magnetic poles. The Earth has its own magnetic environment there. There are so many things, and also the distance from the sun. The Earth sits in what's called a habitable zone. So the Earth sits in an optimal distance from the sun, where it's not too hot, where it's not too cold, where we have water, okay, and the atmosphere for us to respire. So the Earth is, there are a lot of factors that contribute to the Earth being the cradle of life that we know it to be. All right. Part of where I started to understand, or where I started thinking about astronomy and what's happening outside of planet Earth, was at the David M. Brown Arlington Planetarium. I volunteered with the Friends for numerous years, and then I took a hiatus, and I want to go back and volunteer with them. But most of my audience is Black, so I would encourage you, if you know a young person or young persons in your circles who have an aptitude for this stuff, or they can do math and they can read, I would encourage you to take them to your local planetarium if you have one. Okay. Yep. UFO kamikaze. Yep. A Goldilocks zone. That's what it's called. Yep. And that's, I did a stream on Gregory Robinson, who helped get the Webb telescope up into outer space. When the Webb telescope was looking into other systems, that's something that they're looking for. In addition to looking for the elements that are on those planets, NASA and the space community, they're also thinking, okay, how far is that planet away from its star, and is it in that optimal distance, that Goldilocks zone, that habitable zone for life, where it can have water and clouds and an atmosphere that could sustain life. So thank you, UFO kamikaze. Okay. So I have 2 articles I'm going to read here. They're not long, okay, but I'm going to introduce a couple of vocabulary terms first, and then I'm going to wrap this up back at this book here, Dark Winter, because again, this is this idea that the climate on our planet is in part impacted by the activity of the sun. That's almost never discussed. Everything is global warming. Everything is climate change, but no one ever talks about openly what the sun is doing. Okay, and that's discussed in Dark Winter, and as we know that the mainstream media, society, certain narratives are driven on purpose, and I'm going to stop that there because I don't want this video, I don't want this stream removed. So I'm going to introduce some vocabulary words here. Let's talk about, let's do a solar cycle. What is a solar cycle? Because in Dark Winter, the theory that John Casey pushes forward, and I'm not saying for the YouTube algorithm, I'm not saying this is true. I'm saying this is a theory. The theory that he pushes in the book is called relational cycle theory. Relational cycle theories. That's the theory that the climate on the Earth is being impacted by the output of the sun, and that the output of the sun is not static. It's not uniform. The output of the sun actually goes up and it goes down. It goes up and it goes down. And this has been happening for thousands and thousands of years. Okay. So what is a solar cycle? And this is coming from the NASA website. There's so much going on the Earth: wars, pandemics, dollars inflating, that we never think about what's happening in outer space. Most people are not thinking about that. They're thinking about social media and Twitter, but there's a lot going on, a lot of fascinating things going on. This is from the NASA website. What is a solar cycle? Short answer: the solar cycle is the cycle that the sun's magnetic field goes through approximately every 11 years. Okay? So it's not, when we look at the sun from the surface, all we see is this glowing dot that you can't look at for too long because it'll hurt your eyes. but its output, it's fluctuating, and I'm going to describe that. Our sun is a huge ball of electrically charged hot gas. This charged gas moves, generating a powerful magnetic field. The sun's magnetic field goes through a cycle called the solar cycle. Every 11 years or so, the sun's magnetic field completely flips. This means that the sun's north and south poles switch places. Then it takes about another 11 years for the sun's north and south poles to flip back again. The solar cycle affects activity on the surface of the sun, such as sunspots, which are caused by the sun's magnetic fields. As the magnetic fields change, so does the amount of activity on the sun's surface. I don't know. Fair use. I think it'll be okay if I play this cartoon. I don't even know if there's sound. If there's sound with this cartoon, I'll stop it because I don't want a copyright strike. But I think this is just a visual of how those poles flip. So let's take a look. Fair use, fair use, fair use. Fair use. Fair use. Okay. I think when you do the fair use thing, you have to stop it at some point, because I think there's a time threshold. Okay. I'm going to restart it, and then I'm going to stop it, and then I'll continue reading. Okay. So this is a simulation or a model of how the sun actually works. And I think those lines, those squiggly lines outside of the center of that represents the magnetic field. Okay. I'm going to drop this link. This link is below in the description box, but I'm going to drop it in the chat in case anyone wants to go there and take a look for yourselves. So that's there. If you're just coming in, please hit the like button. The likes are free. All right. One way to track the solar cycle is by counting the number of sunspots. So John Casey talks about that in the book as well, the number of sunspots on the sun. The beginning of a solar cycle is a solar minimum, or when the sun has the least sunspots. Over time, solar activity and the number of sunspots increases. The middle of the solar cycle is the solar maximum, or when the sun has the most sunspots. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Okay, so there's a illustration of that. I just dropped the link there in the chat in case anyone wants to take a look. But again, that right there, as we're going throughout our work days and our work weeks, most people assume that the sun is just radiating and it's just doing what it's doing at a constant output. But no, it's changing. It's the sunspots are changing. The poles are flipping. So that right there, I think, is worth the price of admission. Giant eruptions on the sun, such as solar flares and coronal mass ejections, also increase during the solar cycle. These eruptions send powerful bursts of energy and material into space. This activity can have effects on the Earth. For example, eruptions can cause lights in the sky called aurora, or impact radio communications. Extreme eruptions can even affect electricity grids on Earth. That's going to be an article I'm going to read. Some cycles have maximums with lots of sunspots and activity. Other cycles can have very few sunspots and little activity. Scientists work hard to improve our ability to predict the strength and duration of solar cycles. These predictions can help them forecast these solar conditions called space weather. Forecasting of the solar cycle can help scientists protect our radio communications on Earth and help keep NASA satellites and astronauts safe too. Solar activity can affect satellite electronics and limit their lifetime. Radiation can be dangerous for astronauts who do work on the outside of the International Space Station. If scientists predict an active time in the solar cycle, satellites can be put into safe mode and astronauts can delay their space walks. Okay, so that's a discussion on what solar cycles are. Okay, and that link is right there in the chat. Thank you to those of you who are hanging out here. Jake King says, I like to think about what could be going on, but maybe the powers, that's part of it too. Yeah, maybe they don't know what's going on. I mean, what you study, if you think about studying something like the sun, you can't control it. All you can do is observe what it's doing and what it's radiating, and I guess how its poles are shifting. UFO Kamikaze says planetary disruption of rotation and orbit over time can impact Earth's Goldilocks zone positioning. Yeah. Okay. This one is an actual discussion of what solar minimums and solar maximums are. Okay. And also keep in mind there are 7 other planets orbiting our sun. So that there's a gravity context to all of this as well. Okay. This is also from the NASA site. So solar minimum, solar maximum. Okay. The picture on the left shows a calm sun from October 2010. The right side from October 2012 shows a much more active and varied solar atmosphere as the sun moves closer to peak solar activity, a peak known as a solar maximum. And one was predicted, this is November 26, 2012. So one was predicted for 2013. Okay. The sun goes through a natural solar cycle approximately every 11 years. The cycle is marked by the increase and decrease of sunspots, visible as dark blemishes on the sun's surface or photosphere. The greatest number of sunspots in any given solar cycle is designated as a solar maximum. The lowest number is a solar minimum. The solar cycle provides more than just increased sunspots. However, the sun's atmosphere or corona, bright active regions appear, which are rooted in the lower sunspots. Scientists track active regions since they are often the origin of eruptions on the sun, such as solar flares or coronal mass ejections, CMEs. The most recent solar minimum occurred in 2008 and the sun began to ramp up in January 2010 with an M-class flare, a flare that is 10 times less powerful than the largest flare labeled X-class. The sun has continued to get more active with the next solar maximum predicted for 2013. Okay, the journey towards solar maximum is evident in current images of the sun, showing a marked difference from those of 2010 with bright active regions dotted around the star. High resolution imagery from this article is available at that site. I'm going to drop this link in the chat in case anyone wants to read it and save it for yourselves. This is also in the description box below. Okay. I have 2 more pieces to read. Now, everyone, keep in mind that the magnitude of the solar maximum and minimums, they're not the same. Okay. So they can vary in magnitude, and that's talked about in this book as well. Okay, so they're not all the same. All right, this is the article that caught my attention and made me say, okay, maybe I should do a stream on this. So this one is entitled. This one was published last week. This is entitled "A strong geomagnetic storm is leading." I'm sorry. A strong geomagnetic storm is heading towards Earth, space forecasters say. Okay, this is the article that caught my attention. If you're new coming in, please hit that like button. The likes are free. I don't have a super chat or AdSense over here. So if you want to make a donation, even a small one, my Cash App and PayPal are right there. Okay. This was written by Dylan Stableford on Wednesday. Okay. A strong geomagnetic storm caused by the sun could impact Earth later this week, space weather forecasters say. So I didn't notice anything unusual at the end of last week. You guys can let me know if you did, but I didn't notice anything. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center on Wednesday issued a geomagnetic storm watch following recent explosions on the sun that have triggered strong solar flares and multiple coronal mass ejections that could reach the planet on Thursday. Okay. NOAA defines a geomagnetic storm as a major disturbance of Earth's magnetosphere that occurs when there is a very efficient exchange of energy from the solar wind into the space environment surrounding Earth. The largest storms that result from these conditions are associated with solar coronal mass ejections, where 1 billion tons or so of plasma from the sun with its embedded magnetic field arrives at Earth. While most of this week's disturbances are expected to have little to no impact, there is a chance that the expected storm could reach a level of 3 out of 5 on the geomagnetic storm severity scale. Okay. I'm not going to play this. Again, I don't want to strike against the channel. But if you guys want to look at this yourselves, the link to this article is here. That could cause power grid fluctuations and briefly disrupt satellite, radio, and GPS communications, NOAA said. The geomagnetic storm's arrival also means that the northern lights could be visible as far south as Iowa on Thursday. According to the official space forecast, the auroras might be seen over the far northeast to the far upper Midwest, across portions of the north central states, and perhaps over the northwest section of Washington state. While the auroras are not uncommon, the likelihood of a collision of multiple coronal mass ejections, a celestial event referred to as cannibal coronal mass ejections, some sky watchers anticipating a brighter than usual light show. In July, the northern lights were so bright that photographers captured the colorful show even in the heart of Seattle, where light pollution typically mutes visibility, Fox's Andrew Wolfbeck said. Okay. Others are just excited about the solar eruptions. The sun just hurled a plume of cool, dark plasma into space, astronomer Tony Phillips wrote in a blog post. Don't miss the impact. If you do miss it, though, don't worry too much. NASA said last month that in the current solar cycle, solar events will continue to increase as we near the solar maximum in 2025. Okay, so there's another predicted solar maximum coming in 2025. Okay, that's the image. Okay, so I have solar maximum. Talked about solar maximums. And I'm going to read this last one because, and then I'll wrap up. I'm going to read this last one because this is, I believe this is discussed in Dark Winter, the concept of the solar wind, which is, this is a illustration of a solar wind here. And this is also another illustration of a solar wind here. Okay, so I think what I'm trying to communicate is that the sun, there's more coming from it than just light. Okay, and the argument that the author of this book makes is that the solar wind generated by the sun can impact our weather patterns. Okay, I was looking for articles online prior to the stream that kind of linked the solar wind to our weather patterns, but I couldn't find anything. It might be there is no link. It might be that the information is buried somewhere. And he makes the argument in the book that, again, that's a theory that is not as popular, number one. And number two, it hasn't gotten a lot of support. So it could be that it's there, but it's just buried somewhere. Okay, my mother is home. Let me shut this door. Give me 1 second here. All right, everyone, I'm back. So we're going to end with the concept of the solar wind. Okay. Solar wind, what is it and how does it affect Earth? Any way the solar wind blows, its effects can be felt throughout the solar system. Okay. The link to this is here, in case there are any curious souls out there. And this reads as follows. Oh, I think I'm on the wrong article. Hold on. Okay. Solar wind. What is it and how does it affect Earth? Any way the solar wind blows, its effects can be felt throughout the solar system. This image says, solar wind is continually released from the sun's outermost atmosphere. The artist's illustration shows solar wind streaming out from the sun. Okay. The solar wind is a continual stream of protons and electrons from the sun's outermost atmosphere, the corona, not the beer. These charged particles breeze through the solar system at speeds ranging from around 250 miles per second to 500 miles per second in a plasma state, according to the National Oceanic and Atmospheric Space Weather Protection Center. When the solar wind reaches Earth, it sends a flurry of charged particles into the magnetosphere and along Earth's magnetic field lines towards the poles. The interaction of these particles with the Earth's atmosphere can produce glowing aurora displays above polar regions. So I think that would be the northern lights in Iceland. I think that's what that would constitute, or that's how that would manifest. The existence of the solar wind was first proposed by pioneering astrophysicist Eugene Parker, whose name graces NASA's Parker Solar Probe mission. In 1957, Parker was working as an assistant professor at the University of Chicago when he realized the superheated corona of the sun should, in theory, emit charged particles at high speed, according to the University of Chicago. Parker's theory described that in the sun's corona, plasma is continually heated with temperatures in this region reaching a blistering 3.5 million degrees Fahrenheit. Eventually, the plasma becomes so hot that the sun's gravity can no longer hold it down, so it is hurled into space as the solar wind, dragging the sun's magnetic field along with it, according to NASA JPL. His theory was widely criticized at the time. Parker recalled in 2018, the first reviewer on the paper said, well, I would suggest that Parker go to the library and read up on the subject before he tries to write a paper about it, because this is utter nonsense. So that right there, you can see these theories, they're not easily and readily accepted. They're criticized, and they're ground truthed, and they're vetted by other members of the community. So these things, when they're proposed, are not readily accepted. Support of this theory finally came from astrophysicist this person is Indian, Subramanian Chandrasekhar. Right, I'm just going to do that once. I just butchered this person's name. Who decades later became the namesake of NASA's Chandra X-ray Observatory. Though Chandrasekhar wasn't fond of the particle idea, he accepted Parker's theory because he could not find any issue with Parker's mathematics, the University of Chicago said. Then in 1962, NASA's Mariner 2 spacecraft detected the presence of solar wind particles during its voyage to Venus. In addition to the constant streams of solar wind, the sun sometimes expulses massive quantities of those charged particles in one go. These events, known as coronal mass ejections, can trigger geomagnetic storms in the environment around the Earth, which are associated with the beautiful aurora displays, but can also wreak havoc with power grids, telecommunication networks, and satellites orbiting the planet. Okay, so this is a little cartoon here. Of the sun and the earth, of the solar wind and the earth's magnetosphere. Again, it's in that article. If you're just coming in, please hit that like button. The likes are free. If you want to make a donation to the channel, if you're learning something here, my Cash App and PayPal are here as well. Royston says, thank you, Dr. Dunbar. You are welcome, Royston. Thank you for being here. Thank you for your support. Okay. The solar wind sweeps through the solar system far beyond the orbit of Pluto, forming a large bubble around the heliosphere. According to NASA, the heliosphere is shaped like a long windsock that moves with the sun. The closest boundary of the heliosphere is about 100 AU from the sun, according to an ESA statement. When AU, or astronomical unit, is the average distance from the Earth to the sun, it is equivalent to roughly 93 million miles. The heliosphere acts as a protective shield, defending us against cosmic rays consisting of energetic particles that can damage living cells. Uh, Comic rays, I'm wondering if that's cosmic. I'll say cosmic. Cosmic rays are generated outside of our solar system and blaze along at almost the speed of light. Without our protective bubble, these high energy atom fragments would constantly bombard Earth. Without the heliosphere, life would certainly have evolved differently and maybe not at all, says heliophysicist Richard Marsden in the ESA statement. Okay. That is NASA's this is from NASA's Solar Terrestrial Relations Observatory. The GIF visually represents the computer process data of the solar wind. Okay, we're almost done here. Once again, please hit that like button. The likes are free, and that helps with the engagement. Though the solar wind flows from the sun constantly, its properties, such as density and speed, vary throughout the sun's 11-year cycle of activity. During the cycle, sunspot numbers, radiation levels, and ejected material ebb and flow from a solar maximum to a solar minimum. These alterations affect the properties of the solar wind, including the strength of its magnetic field and the speed at which it travels, temperature, and density. The average constant solar wind speed at Earth is around 190 miles per second, according to the Space Weather Forecast website, spaceweatherlive.com. During Mariner 2's flyby of Venus, the spacecraft not only detected the presence of the solar wind, but also identified two distinct streams of solar wind, one fast and the other slow. According to NASA, the slow stream was reported to be traveling around 215 miles per second, whilst the faster streams are by at twice that speed. The origin of the fast stream of solar wind was identified in 1973 using X-ray images taken of the sun's corona from Skylab. The culprit for speedy solar winds are coronal holes, cooler regions of the sun, with an open magnetic field line structure that allows the solar wind to escape with relative ease. Abnormally fast solar winds can be generated during coronal mass ejection events. During CMEs, wind speeds can jump up to more than 600 miles per second, according to spaceweatherlive.com. Despite the impressive breakneck speeds achieved by some solar wind streams, it is the slower solar wind that has gotten scientists scratching their heads. The slow solar wind, in many respects, is a larger mystery. NASA's Ulysses mission, launched in 1990, has already revealed some clues to the origins of the slow wind stream. When it flew around the sun's poles, it found that during periods of minimum solar activity, the solar wind originates primarily from the sun's equator. As the solar cycle progresses towards its maximum, the structure of the solar wind changes from two distinct regimes, fast at the poles and slow at the equator, to a mixed, inhomogeneous flow, according to a NASA statement on the Parker Solar Probe and the birth of solar wind. The Parker solar probe will investigate this mystery during its 7-year mission to observe the sun. It offers great promise for revealing a fundamental new understanding. Okay. Let's see. UFO Kamikaze says Aurora Borealis event forecasted for this weekend. Herbert Lewis, what's going on? He says Aurora Borealis are always cool to witness. Okay, let me see how much further this is. Give me 1 second here, guys. Just bear with me for a moment. Herb, I'm doing a Michigan football live stream on Wednesday night. You might be interested in that. It's a preseason stream. I've got Johnny Oldham coming over. Should be a fun time. Okay, there are only 2 more sections to this, so I'll just finish this up. If you haven't, please hit that like button. Okay. The effects of our windy star are felt throughout the solar system. My feeling is if the sun sneezes, Earth catches a cold because we always feel the impact of what happens on the sun thanks to the solar wind, said Nikki Fox, the division director for heliophysics at NASA headquarters, in a NASA Science article. On Earth, the solar wind is responsible for dazzling aurora light shows around the polar regions. In the northern hemisphere, the phenomenon is called the Northern Lights, while in the southern hemisphere, it's called the Southern Lights. The Aurora Australis. Maybe that's where Australia got its name from. Or maybe they named this after Australia. If solar wind speeds are high enough, geomagnetic storms can be triggered, which can lead to auroras expanding closer to the equator than is possible during calmer space weather conditions. And then finally, I think this is the ending. That's a picture, that's an image of the Northern Lights. I'd like to go see that one day. I think you have to go to Iceland to see that. I'd like to see that with my own eyes one day. Geomagnetic storms can also wreak havoc with satellites and electricity networks and threaten astronauts in space. During these storms, astronauts on the International Space Station need to seek shelter, and all spacewalks are paused, and sensitive satellites are powered down until the radiation storm has passed. SpaceX has already witnessed firsthand the damage space weather can do when a geomagnetic storm destroyed up to 40 Starlink satellites worth over $50 million in February 2022. As Starlink satellites are released into very low altitude orbits, they rely on onboard engines to overcome the force of drag, raising themselves to a final altitude of about 350 miles. During a geomagnetic storm, Earth's atmosphere absorbs energy from the storms, heats up and expands upwards, leading to a significantly denser thermosphere that extends from about 15 miles to approximately 600 miles above the Earth's surface. A denser thermosphere means more drag, which can be issues for satellites. In February 2022, the batch of recent released Starlink satellites failed to overcome the significantly increased drag from the geomagnetic storm and began to fall back to Earth, eventually burning up in the atmosphere. So, so these things can affect the conditions on our planet. Solar weather can have drastically expensive consequences. It is therefore important to increase our understanding, monitoring, and predictions of such events. Scientists study solar wind in a bid to shed light on the space weather environment and improve space weather forecasts. We can't ignore space weather, but we can take appropriate measures to protect ourselves. Okay, that's the end of that. Okay, three more paragraphs. There are three more paragraphs. And for completeness, I'll read them. Heliophysics missions study the sun and its influence on the solar system, including the effects of the solar wind. According to NASA, the goal of these missions is to understand everything from how planetary atmospheres have formed to how space weather can affect astronauts and technology near Earth, to the physics that defines our neighborhood in space. Understanding solar environment is no mean feat, hence why there is a whole fleet of space missions dedicated to understanding our sun and its behavior. These missions can be collectively thought of as a single observatory, the Heliophysics System Observatory, HSO. The HSO consists of several solar, heliospheric, geospace, and planetary spacecraft, including the Parker Solar Probe on a daring mission to touch the sun, the Solar and Heliospheric Observatory, SOHO, a joint effort between NASA and the European Space Agency, the Solar Terrestrial Relations Observatory, STEREO, consisting of two near-identical observatories, one located ahead of Earth's orbit and the other trailing behind, and ESA's solar orbiter that is taking a first-time look at the sun's uncharted polar regions. Okay. So that's that. This link should be below in the description box. Let's see, UFO Kamikaze 1 says, scientists were concerned about the possibility of solar activity disrupting satellite communications a week or two ago. Most are completely unaware of it. Yes, that's true. Let's see, we're at 1 hour here. Going back to this book, and I'm going to wrap this stream up within a few minutes. Again, one of the inspirations for this stream was this book here, Dark Winter by John Casey. And one of the premises for this book is relational cycle theory. And that's referring to how the output of the sun can potentially impact the weather on the Earth. So these pieces that I read, they talked about the solar wind, they talked about the northern lights, they talked about electromagnetic storms disrupting power grids and satellites and space missions, but nothing was said about the actual weather of our planet. Now we know, it's known that the Earth has its own magnetic field, right? And that magnetic field, it protects our planet from things such as the solar wind. Okay. I thought for some reason, I feel like I heard at the planetarium that our magnetic field is either weakening or fluctuates as well. But one of the arguments that John Casey makes in this book is that the solar wind can impact the jet stream. I'm sure all of you have heard the term the jet stream before. I'm not a climatologist. I'm not a meteorologist, but what I do know is that the jet stream impacts the weather in specific regions of the Earth. Okay, I'm going to show this picture one more time. That is a diagram / cartoon of the jet stream. Okay. So if the jet stream gets altered, you're going to see altered weather patterns. Okay. And that is one of the arguments that Mr. Casey makes in his book, Dark Winter, here. Okay. So that whole principle, the solar wind impacting the jet stream and impacting our weather patterns, you pretty much never hear about that when you hear about climate and when they're talking about climate. And I just did a very quick search prior to the stream to try to look for content linking those two together. I couldn't find any, so it's either not there, or it's either buried somewhere, because it's not a theory that has been widely supported by specific parts of the science community, and it hasn't been supported by certain past presidential administrations. But I should probably stop there because I don't want the video taken down. And yeah. I was going to say one other thing. I forgot what it was. Well, if you don't get anything else from the stream, just know that the sun's output is not constant and static. It's fluid. It fluctuates. The poles flip. There's a solar minimum. There's a solar maximum, and there is also a solar wind, which can impact our planet in various ways. So, and again, going back to the initial question, do you believe in science? So someone asks you that. I've been asked that, and it was asked in the context of global warming and climate change. That's a sensitive topic because there are so many people who are passionate about it. But science is not just about believing one theory. It's not just about considering one theory. It's about considering all the theories and considering them together. Okay. Maybe one disproves another one. Maybe they all fit together. But when one theory or certain theories are not at least being discussed openly, I think that's a problem. So, do you believe in science? And if you do, which science do you believe in? Which theory do you believe in? There's pretty much no talk about relational cycle theory, and perhaps that's intentional. So, I will probably revisit this again in the future. I will probably need to be careful though, because again, it's not convenient if certain information is very tightly controlled. So there are certain things that the powers that be, I don't think there are certain things they want us talking about amongst each other. T. Riddler says, the question, do you believe in science, is like asking, do you believe in analysis? Okay. Well, T. Riddler, it can be interpreted that way, but it can also be interpreted as, you see what's happening around us, how come you don't believe it? It's hot or it's cold. But why is it hot? Why is it cold? And is the fact that it's hot, is that unique to 2022? Is it unique to 2021? The fact that it's cold, is it unique to 1980? One of the things when you read this book, if you read this book, one of the things that you might take away, one of the things that I took away from reading this book is that the Earth is old. Our solar system is old, and you have to look at you have to look over hundreds of years, in my opinion, to look at the trends, to look at historical events, and you have to look at the entire vast range of years to look at the weather trends and the patterns to conclusively say, or to get a conclusive idea of whether or not this is a blip in the entirety of events, or if this is an actual seismic event that we're going through. So you have to look across a broad range of years to understand what's really happening. That's what that book taught me. Yeah. So yeah, it could be maybe you don't believe in analysis. Now, do you believe in science? That goes for the religious community too. We know that the religious spiritual community, they believe in a very touchy subject. There is creationalism and Christianity. And I grew up a Christian. I go to church sometimes. The theory is that man comes from Adam and Eve. Okay, it doesn't talk about multiple evolutions of Homo sapien. It doesn't talk about that. The Bible doesn't talk about. It doesn't talk about evolution. The fact that the environment has helped dictate the presence of certain species and the continuation of certain species and the extinction of certain species. Spiritual religious dogma doesn't talk about that. So that's another context for the question, do you believe in science or do you believe in the supernatural? So there are multiple contexts for that question. But the one I'm talking about is, why don't you believe this one theory? So Earth UFO Kamikaze says true. And Herbert Lewis says Arctic ice core samples have shown Earth's relative age. Yeah, the planet is old. Everyone, I think I'm going to wrap up there. Thank you to those of you who watched the stream and listened to me read. I realize that can get a little well, depending upon what I'm reading, that can get pretty long sometimes. I appreciate you guys who have stayed and humored me. Thank you to everyone who liked the stream, and please like it on the playback if you come and watch. And the other thing is, if you guys have topics, if you guys want to hear about certain things, definitely let me know. If you have things, if you have questions about things I've talked about, or if there's something happening that you want to hear about, definitely let me know. This shouldn't just be a one-way channel. I didn't salute AB Media when he came through. AB Media, what's going on? I saw you pass through the chat. If you are watching on the playback and you want to make a donation to the channel, my Cash App and PayPal, let me slow down. My Cash App and PayPal are here. I don't have a super chat or a super thanks or AdSense over here. Got to get the watch hours up, and I have ideas for how to do so. If you want, many of you know that I am a scientist and a writer. And I have let me see if this is still live. Oh, okay. Okay. I have to look into that. Well, I have a newsletter, but I purchased some new features through GoDaddy, and that form is no longer active. So everything has to be updated, and with this technology, everything has to be updated and modified at some point. So the newsletter, I have to look into that. Anyway, everyone, enjoy the rest of your Sunday. Thank you to those of you who hung out for this. Look out for the next stream. The next offering on the channel will probably be another, the last part of my interview with Timothy Newsom. I went to Dallas about 2 weeks ago to interview Timothy Newsom, who is the owner and the chief technology officer for New Tech Business Solutions. I uploaded the first part of that interview on my original channel, and the third part is going to be uploaded here because we're talking about his technology company. So that will probably be the next offering here. I have to edit that, put pictures in, and vice versa. So if you're new here, if the algorithm brought you here, please like, share, and subscribe. Everyone stay safe out there. And as always, remember that your attitude determines your altitude. Take care. I will talk to you the next time. Bye-bye. I'm going to read this comment really quickly. This is from Rawital Vital Vegetari. Never seen you before. Okay, it's an elder. She says, with science, is there any differences in the word man and mankind seen? That's interesting. Is there any differences in the word man and mankind? I don't think so. I think man and mankind, that is synonymous with Homo sapiens and modern humankind. So thank you for that question. UFO Kamikaze says, informative discussion, liked and subscribed. Thank you, UFO Kamikaze, for participating in this. You seem to have a knowledge of astronomy and aerospace a little bit yourself. Before I shut down, everyone, I would encourage you once again, I think most of my audience here is melanated, just like me. And if you have young people in your circle and you're starting to see that they have an aptitude for science and for the sciences, I would encourage you to take them to your local planetarium if you have one. This is the David M. Brown Arlington Planetarium. I volunteered there for a number of years. I'd like to start going back and volunteering with them again. But there we hosted speakers from the astronomy world. We showed full dome shows about space, about astronomy, about astrophysics, about space-time, quantum physics. And for a young person, the earlier they start thinking about those things, you're increasing the likelihood that they will get involved in those careers later on. They'll start thinking about being other things besides entertainers. They'll start thinking about being other things besides athletes. And they'll start thinking about being other things besides politicians or lawyers. Not that there's anything wrong with those careers, but you have to conceive of it first. Okay, and if none of those people are in your family, if none of those people are in your neighborhood, then all you're going to see is being an athlete or an entertainer or a lawyer or a politician or a TikTok star or whatever. So if you know someone in your circle and you have a planetarium close by, I would encourage you, take that young person to the planetarium so they can see a full dome show and they can start thinking about being astronomers and astronauts themselves. So they can start talking about solar minimums and solar maximums and solar winds and MCEs and auroras and gravitational fields and all those things. A lot of families don't know. A lot of kids just don't know. All right. She says human and human being. Yeah, those are synonymous. Herb says, I'd say yes. I'm not sure if you're talking to this lady here. Herb says Neil Armstrong's statement when he stepped on the moon speaks to that. I'm not sure what you're referring to there, Herb. I'll stay for a few more minutes if you want to elaborate on that. Rawatal says, but not program conditioned by. Okay. All right. All right, everyone. Enjoy the rest of your Sunday. Take care. Please like, share, and subscribe. And as always, remember that your attitude determines your altitude. Take care, and I'll talk to you the next time. Bye-bye.